right. It's awesome to see a crowd like this. Good afternoon. Come on, how many people have been to one of these before? All right, so you know, good afternoon. Yeah, there we go, much better. How many people have never been to one of these before? Okay, so I can use the same jokes for those people as I've given before. Welcome to Case of the Unexplained. My name is Mark Russinovich. I'm CTO of Azure as my paid-for job. I'm CTO of Sysinternals as my fun job that I still have on the side to keep myself occupied when I don't have Azure things to do. Now, here's the outline of the talk that I'm going to be going through today. First, I'm going to kind of motivate the reason for this talk. I think that shouldn't be too hard given there's a lot of people already here, so you probably have a good idea for why a talk like this is interesting. And then I'm going to go into different scenarios, different symptoms to show you how to use various tools to go and identify the root cause of these problems. But the reason this talk is still so popular, and it's been almost, I think, 10 years that I've been giving this talk at every tech ed and IT forums and now Ignites, is that every talk is different. And that's one reason that so many people come back. But the fact is that most applications do a really poor job of telling you when they run into a problem about what the root cause of the problem is. And there's a very simple reason for this. Writing software is a complex task, and there's always deadlines for the developers to hit. So what often gets left behind are all of the funny cases in the code where there's unexpected circumstances, and making sure that the code deals with those in a reasonable way. So for example, if there's a registry key that's missing, or a file that has permissions set on in a way that the developer didn't anticipate, the code might not even check to see if that's the case, continue on as if everything was fine, and then end up going off into the weeds. For example, referencing a pointer that's not valid, or reading contents out of a buffer that are garbage because they were never initialized with the contents of a key. And so the way that the code will often react to garbage like this is that it'll throw up a dialog box that points at a problem that has nothing to do with the root cause. It'll say, when there's a missing registry key, hey, you don't have administrative permissions, having nothing to do with the fact that there's a missing registry key. Or it might crash or hang, or just hang indefinitely waiting for something, or hang consuming the CPU. I've got a collection of some of my favorite misleading dialog boxes. I'm sure you've seen many like this. This is my favorite, I think, of all time. And this I still get from Outlook every now and then. It's unknown error. The response that it asks for me for that is OK. And then it has the audacity to ask me if the information was helpful. Here's another one. This is from Visual Studio. I didn't know there was such a thing as zombie processes. Have you seen this? This is pretty frightening. Catastrophic failure. It's like my computer's like, or the world is ending or something. And Windows has detected it. And then we just kind of gave up on it. And then we tried to be funny about it. So those are all examples. By the way, this is what end users see when they see a dialog box. Somebody tweeted this about 6 months ago. Something happened and you need to click, and you need to click OK to get on with things. Certificate, and then there's the fine print, certificate mismatch security, identification, administration, communication, intercept, Lilliputian, snow weasel, foxtrot, omega force. Press button for technical crap. And then there's options for levels of technical crap. So the purpose of this talk is to give you a look behind the scenes of problems like this so you can understand and find out actually what the root cause is. We're going to take a look at a bunch of tools to look at registry activity, file system activity, networking, and DLL and process activity. And one of the key troubleshooting tools for getting to the root cause of one of these types of problems is understanding a call stack. Because in many cases, the piece of code that throws up the dialog box really is indirectly to blame for the cause of the problem. Some other DLL, typically, or component has fed it some garbage, and it's just responding as it should to that, and then runs into a problem. And it's really the cause of something that's further up in what's called the call stack. And we're going to look at how to interpret a call stack so you can see when that's the case. The tools that we're going to use are the Sysinternals tools. How many people have used Sysinternals tools? Raise your hands. All right, how many people have not used a Sysinternals tool? Is there anybody? Anybody I need to have escorted out of the room? So we're going to be using those. Is that a train coming through? We're going to be using those, and we're going to also be using a tool called the Windows Debugger, which is a tool to look at crashes and hangs. So that's the only non-Sysinternals tool we're going to be using. This list isn't all of the tools that I'm going to be showing, but like I said, every one of these presentations is unique. Everyone has a different set of troubleshooting cases submitted by you or me or others. And so everyone's unique, and so, some presentations use some tools and some use other ones. So I recommend that if you like this presentation, you go take a look at my blog on Sysinternals, and you'll find a list of the links to to previous year's cases that Unexplained. Now this isn't a very auspicious time for me, because the anniversary of Sysinternals, 20th anniversary of Sysinternals, was last week. So I founded Sysinternals with Bryce Cogswell in September of 1996. And you can see a screenshot of the homepage. So I designed it. Yeah, you're like, who the hell designed such an awesome looking website? That was me. I became proficient at HTML before which is a skill that I still use to this day. And you can see how hip and cool we were. If you remember surfing the web in 1996, you did not have a website that was cool and interesting unless it was constantly under construction. So we had the under construction logo there. And there was a party this summer hosted by Sammy Leo. How many people have heard of the party, or anybody been there? So a few of you, yeah. So this party was to celebrate the Sysinternals 20th anniversary. I give a remote keynote via Skype, which crashed in the hotel room halfway through, so I ended up giving about 20 minutes of talk on Sysinternals to nobody listening, but here's a collection of some of the auspicious speakers that spoke there on various tools, including one, Aaron Margosis there. How many people have heard of Aaron? So Aaron, where are you? Are you here? He's here? Oh, darn. So I can't talk about him behind his back. But here's Aaron giving a talk. And he told me, and he came back, Mark, I gave a talk. My talk was the best talk. Everybody was so interested in my talk. And then I was surfing the website after the conference, looking at the pictures, and it was like, here's pictures from Aaron's talk. And I'm like, oh yeah, they look really interested, Aaron. No, Aaron did give a good talk. So speaking of Aaron is my co-author on a book called Windows Sysinternals Administrative Reference, which came out about 4 years ago. And it was a tool that we worked on together. And when I say we worked on together, he wrote almost all of it himself. And then I put my name on it. And this book is the official reference. And now we've just finished the second edition of the book. In fact, Aaron took a really long time writing this, so I got more and more involved as the book went on. I went from emailing him once a month to once a week to every day. So that was my level of involvement, how I had to step up my game to get this book out the door. And we got it out the door, and he did a pretty good job on this one. So good that I decided, yeah, sure, I'd put his name on the cover again this time and actually make it the same size. So this book is coming out in a month, literally about 4 weeks. You can pre-order it right now. In fact, I've got 25% off discount sheets right here that you can go down to the bookstore and you can get 25% off. And then Aaron's here, so we've got a stack of little things that we can sign for you, so when the book comes, you can slap on our signatures. So after the session, come on up to the stage and I'll be handing those out. All right, so let's get into the meat of it. Let's start with sluggish performance. How many people have seen a computer with sluggish performance? And I'm not talking about Windows Vista. Yeah. Okay. So pretty universally applicable So this case starts with somebody that noticed that their system was running sluggishly. The mouse was jittery, processes, application would take a while to launch, and they ran a tool called Process Explorer to try to figure out what was going on. I'm not going to ask how many people have used Process Explorer because I assume that I'm just going to get a lot of hands going up, but we're going to spend just a few minutes going through a tour of Process Explorer to understand what it shows you and how that's different from other tools like Task Manager and Resource Monitor, and how it can help you troubleshoot particular problems like this one. One of the key aspects of it is that it shows you things in the processes in a indented way. And this indentation shows you the relationship between the processes, the parent-child relationship. So anything that is indented and beneath another process is a child of that process, or a descendant if it happens to be indented more than once. And so you can see some interesting things just by looking at the indentation. Like you can see WinInit here launches a bunch of system processes, including services.exe, which is the service control manager in Windows. That's visible right here in the process tree. And then down here you can see Explorer. That's the shell process for my login session. And so just about everything I create is created by Explorer. When I go into Explorer and I double click on an application, or in the start menu, I double click on a Win32 desktop application, this will be a child of Explorer. There are some of those modern UAP type of applications that will not be launched from Explorer. We'll take a look at where they show up here in a second. So that's one of the first things you see. Another thing that you notice is that there's color highlighting that you don't see in these other tools. So you see some blue processes, you see some red processes. Does anybody know what blue processes are? Male processes. No, there's no such thing as male or female processes. These are democratic processes. I'm just kidding. It's probably not the right time to make a joke like that. And so the blue processes are processes that ran in my user context. So that explains why Explorer and everything underneath Explorer is just about everything underneath Explorer is highlighted that way, because they're all running as Mark. I'll show you in a second how I can see they're running as Mark. And then the red processes are ones that are hosting Windows services, which explains why there's so many of them that are under services.exe up here that we were just looking at. Like a service host here is hosting Windows services. You can see CPU column, private memory usage column, and working set being physical memory assigned to the process. And then you can see a couple of other columns here that are there by default, the process ID, the description, and the company name. The description and company name come directly from the image itself. So it's not like Process Explorer has a database inside of it that it's looking these things up in. They're embedded in what's called the version resource of the image, and there's APIs that a tool like Process Explorer goes to pull this stuff out. Developer or companies put that in to identify what the thing is. You want some more information about the process, you double click on it. And so I'm going to explore a little bit one of these service hosts, this one right here. And you go to the image tab and you can see information about it. This is the host description and company name. You can see the version. You can see when the primary executable was built, compiled. You can see when it was started down here. So down here is the start time. By the way, the tool, anybody know what tool I'm using? This is Zoomit, and this is a Sysinternals tool. And Zoomit, you can do all sorts of things in it, like draw lines, draw circles, draw smiley faces. Like that. You can type text, I just showed you. And this is a drawing page, but what I can do is I'm in what's called live zoom here, and I can go right from live zoom to annotated zoom, so I can just highlight things on the screen. So this is Zoomit, and that's what I'll be using to identify things here. So I mentioned that we can see the start time here. We can see the command line and the current directory. And so this can be useful information for troubleshooting. In fact, I've got a case in this very presentation that makes use of this information. Oops. Now I'm going to briefly go through the rest of the columns, not spend a whole lot of time on them because we want to get back to the meat. But there's a performance column. This will show you CPU, I/O, virtual memory statistics, physical memory statistics, handles for the process. You can see some of these things in graphical form, so you can see a history that's timestamped, so I can see if this thing has a memory leak, I'd be able to see how it was leaking over time. This graph would be rising. I'd be able to see if there was a memory spike or a CPU spike, when exactly it happened by hovering the mouse over it. There's disk and network statistics for how it's using the disk and network. If it's a process using the GPU, we'd see GPU usage here, including memory usage and the actual computation on the GPUs. This being a service process, there's a tab here called Services. This shows what services are hosted inside this process, including the display name as well as the path to the DLL. In the case of a service host, it's what's called a hosting process. There's other examples like Run DLL32, you've probably seen. It's notorious for being the home of malware because when you look at a tool like Task Manager, you just see Run DLL32. You don't see what it's hosting, what DLL. And when you take a look at Process Explorer, I'll show you how it shows you what it's hosting inside of it. Now, if it's a service hosting process like this, you will see a Services tab because there's a well-defined way of getting that information. Then there's the Threads tab, which shows you the threads in the process and where they started, even tagged by which service it is. So if you see a spike in CPU usage here, you can identify which service in a service hosting process is responsible. The TCP/IP tab will show you the network endpoints, UDP and TCP, that it's got open. You can see this one has a whole bunch of them, and that's because you can see that it's got various services there, like terminal service and DNS cache, network location awareness service, that all have ports open for communication. The security tab, remember I told you how you can see what something's running as. Here's one way to see it. I've also got it over here on the image tab, so that network service, here you can see as well here, network service. And then you see information about the process token, which represents which user account it's belonging to, which we see up there at the top, as well as which groups it belongs to, and then what system privileges it has. So is it able to reboot the machine, for example? That would be a privilege in that lower pane. Environment variables, which can be useful for the case where you've got a program where it's going to read some setting, environment variable setting, and that's only visible through an interface like this. What environment variables does it have? Maybe it's set differently than other processes on the system. And then finally, strings, which is used for malware hunting. So you can look inside of a process's image as it's loaded into memory or on disk and see what printable characters it's got in it, which can give you an idea of what it's doing, what it's associated with in the case of an unknown process. That's a quick look at that. Now, a couple more things before we move on. One is this lower pane view. This lower pane view is the DLLs hosted in the process. And so we're going to see for this service hosting process both two types, memory mapped files and executables. The DLLs are executables, and then memory mapped files like these up here. There's a catalog database. These catalog database files that are mapped into its address space, they will show up here as well. And you can see the same kinds of information for these, like here's the IP helper information about that, similar to what we saw on the image properties. So you can dig into that level of detail. And then there's a handle table view. These are the open operating system resources the process has. The reason this can be interesting is if you've got a handle leak, you can go find out what's leaking a handle. But this is also useful in other ways. For example, I've got a directory here called can't delete me, and when I try to delete this, oh, I can delete it. That's because I didn't set up the demo properly. I tested it and I forgot to do something. So let's try that again. Okay, so now that shows up again, and now when I try to delete it, it says, no, I can't. And trying again will just fail because the condition that I just created is still there. Now, what is that condition? If I do a search like to see can't delete me, what Process Explorer is doing is searching through all the handle tables and DLL mappings to find which process has anything with a resource open that refers to that, and you can see that that command.exe open, because its current directory is in that directory, there's a handle to that directory, which explains why Explorer won't let me delete it. So this is a way to go find out those locked files. There's system information views as well. So what I was showing you, process level, but there's system level information. Here, specific graphs on CPU, memory I/O, as well as a summary. And then, finally, there's a couple things to be aware of. Some options. Here's one option that I recommend you do. Replace Task Manager. So if you want to use Process Explorer instead of Task Manager as your process investigation utility, you simply check that, And now Process Explorer becomes your task manager. What's your favorite way to launch Task Manager? Control-Shift-Escape, that's my way too. Control-Shift-Escape, and there we go. That's Task Manager now. So, and then you can set it to run when you log in, and there's various other options up here. So that's a quick overview of Process Explorer. Back to this case. This user noticed that a script was consuming excessive CPU. In fact, it's that PowerShell nonsense that's being launched here. I say that nonsense because hopefully Jeffrey Snover will watch this. And this is being launched by a WMI provider hosting process. There's other ways that you can see what's inside of a process besides what I showed you, by the way, which is to look at the tooltip. So that service host I showed you, here's another way of looking at the tooltip to see what's in it. And this applies to run DLL32, DCOM host, and WMI provider hosting processes like the one we see there. So you can see which WMI providers are in a particular one of those. In this particular case, the user saw a bunch of that activity. Here's a blow-up of it. Consuming excessive CPU. You can see it's 20% on one, 50% of their processes just coming and going. So they looked at the properties and saw this, something I didn't highlight, and that is that when they looked at that PowerShell script, they looked at the auto start location in the image properties and see that it's launched as a scheduled task, the telemetry host production task. And so to fix this problem, which reoccurred on a regular basis, they went and looked at the scheduled tasks, and here it is, and what they did was disable the task. And they can also see, by the way, that the author is a Microsoft author. In fact, this is an internal from a Microsoft corporate user running into MSIT scripting gone haywire on our corporate network. And I'm sure none of you have ever seen that happen before on your corporate networks, because you're probably all the IT people that will deny that that ever happens. But in this case, it did. And so what they were able to do was immediately disable that and contact MSIT and have them fix that script. This next case is another interesting one. Very different types of symptoms, and I've got a video of this one to show you what this user experienced. And this was on this one particular server, server 2008R2, they go to tile view, and you can see that these icons on these files are really sluggish to refresh. And then they go to their Windows 7 machine, or Windows 10 machine. They go to the same thing, go to tile view, and you can see they redraw just about instantly. So the question was, what's the difference between these two machines? It's the same WebDAV share. So for that, they turned to a different tool. Is anybody familiar with Process Monitor? See, raise their hands for that one. Anybody not use Process Monitor? This one I expect to see some. And I see everybody's afraid to raise their hands to answer that question now. But Process Monitor is if you ask me which is the most useful Sysinternals tool besides Zimit, I would say Process Monitor. And the reason Process Monitor is so useful is that it solves so many problems where you would just not even think that a file system registry monitoring tool would lead you to a root cause. It'll show you sluggish performance root causes. It'll show you hang root causes. So it's so powerful that when my daughter comes home and she's got a homework problem, I have her run Process Monitor to try to figure out what it is. It's so useful that about 80% of the cases I collect are solved with Process Monitor. And my co-author on Windows Internals, Dave Solomon, he came up with an expression a while back called when in doubt, run Process Monitor. We've recently updated it to keep calm and run Procmon, because that's the cool meme these days. And so I've got a shirt that's the previous iteration of this, keep calm and use Procmon. This shirt, you can go, I think it's procmon.aka.ms. Chris Jackson, who's a friend of ours, me and Aaron's at Microsoft, he went and designed these t-shirts, and now you can go buy your own keep calm and run Procmon shirt. In fact, I think if there's one takeaway from this session, it is keep calm and run Procmon. So let's all say that together. And I know I'm asking you to trust me on this one. So this one is just a leap of faith, just to say it. And then by the end, I hope you'll be cheering it when you see what it can do. So ready? 1, 2, 3. Keep calm and run procmon. All right, see, that was kind of lame. So hopefully I'll convince you to be a little more energetic about it. All right, so let's take a look at the actual files involved in this case. And this is an awesome example of a key troubleshooting technique, which is side-by-side comparison. So we've got a trace from the good system. Actually, you know what? I didn't even introduce Process Monitor. Let me do that first before we dive into that particular case. I'm going to just launch it here. And I'm going to just leave it running while I talk a little bit about what it's doing. The first thing you see is column view, time of day, process name, process ID, operation, path, result, and detail. Just basic information about individual operations. For a file system operation, you can see file system operations by the icons here. These are the old FileMon from the original Sysinternals, NT-internals back in 1996. Still preserve those icons there. FileMon, which is actually the old, what was it called? Anybody remember what the Windows 3.1 thing that had that icon? File Manager? Yeah, File Manager icon. You can see that this particular operation is a query security operation. You can see the next one's a create map file. You can see close file and create file, and then the result, so you can see success, and then the details will show you detailed information about that thing, like this is an open as opposed to creating a new file or overwriting one. You can see the desired access here is read. You can see that it's open for reading and writing share mode. Sharing violations are sometimes problems that you troubleshoot in this way by looking at this. And then you can see that this actually wasn't performed by the process that by the user this process was running under, but rather by me. So this process was impersonating me when it went and tried to open this file, as opposed to operating as its native identity. That also can be an interesting troubleshooting signal. So that's a look. You can see there's, if we scroll down, registry activity, so reg open keys. You can see results. But if you want more information about a particular event, including which process it executed it, you go to this Event Properties tab, and this will show you all of the detail about that event. Thread ID, class, operation, so a bunch of that stuff shown in the main display. And then you can see the process information. This is similar to what you see in Process Explorer on purpose. So the version of the executable, the command line of the process, the parent ID, the architecture, the user account, the session ID, and then a list of DLLs, kind of like the DLL view. This is interesting, though, because it's a DLL view at a point in time. At the point that this process, Windows Explorer, was running, these are the DLLs loaded into it. If I went and performed an operation that caused it to load other DLLs, we wouldn't see that here, but we would see those further on in the trace. We'd actually see the load DLL calls in the trace as operations, and then we'd be able to look at the properties and see that DLL show up in that lower pane. So that can give you an idea of what's actually active in the process around the time of a problem, including the version number, because that is also something that it shows for the processes right there. And then the last column, the stack, we'll come back to later. There's also some summary views that are interesting that I'll also show you in a later troubleshooting case. But one of the fundamental skills for using Process Monitor effectively is filtering. How many events have I collected while I've been sitting up here and talking? Almost 3 million events just in the couple minutes I've been talking. Way too many for us to make any sense of if we're looking for a problem. So the key is zooming in on exactly what you think is related to your problem. That could be a particular process. Like, let's see how many of these events are related to Explorer. Actually, I've got 3 million events, so this will take, it's only going to take another 15 minutes. So what would you like to talk about? I'm just kidding. We're going to cancel that and shorten this a little bit. Let me start a new trace and then highlight this capability. So let's say we just want to see Explorer. I just filtered just Explorer. Let's say that if we just want to see reg open keys that Explorer does. Oh, and we just want to see references to this key. So we've just set a bunch of filters to zoom in very quickly onto all activity related to a particular registry key. In some cases, we can't easily find the process that we're interested in. So let me do Control-R to reset. And so we can go and set a filter for a process or a subtree of processes. Like, we want to see everything that this service host has done, and that might be nothing at this point, given let's really do Explorer. So everything that Explorer and its children have done in the trace that I collected here, I can say add process and children to include filter. And this, by the way, shows you a list of all the processes, kind of timelines of when they existed relative to the trace, and summary information, the company name, the owner, the command line, the start time, and the end time. So a good summary of what's going on in the trace. And now I've just seen everything. MMC, snap-in is a child of this. Explorer that is also active at that point in time. So really great way to zoom in on particular activity. And that is the basic interface to the filters. If I want to do something more advanced, I can open up the filter dialog. And you can see when I did that include process and sub processes, what this did was add all the process IDs as include filters to the filtering. And this is an OR operation by column and an AND across columns, which is why I was able to quickly filter down on that particular registry path. And you can see that there's some exclude filters by default. Worth knowing that you're not going to see activity from the system process, which hosts a bunch of device drivers. You're not, by default, you can turn off the advanced filtering to see that, and you're not going to see activity from Process Monitor itself, Process Explorer, auto runs, the basic Sysinternals tools, which you presumably aren't interested in troubleshooting with this. And then you can set up complex filters like I want to see path begins with C temp, and then we can see if there's anything that accessed my temp directory. Nothing did, but if I say OK, and then I come back to this command prompt, what I just did was generate a bunch of activity in that directory. So really powerful ways to filter, and that is, if you want to be a process monitor master the filtering. Okay, back to our regularly scheduled program. Remember, we've got the slow WebDAV problem. How do we troubleshoot that? Run process monitor, and I've got this 2 traces here. This is the not good one, and you know what? Before I show this, I'm going to get rid of some columns that we're not interested in, the time of day column, as well as the process ID column we don't care about. And now we've kind of just reduced the noise. I'm going to open up the good comparison. So we captured a process monitor trace on this other one. Say reset. And now I've got a side-by-side. So the first thing he did, by the way, was he said, maybe there's something interesting about the left side not working, where it ran into some errors that the right side didn't. One of the most common sources of problems when it comes to errors in operations is access denied, permissions being too strict. And the way that you can quickly see which kinds of errors show up where is to do count occurrences here and say result. So you can count anything, the process, unique processes, the unique paths, unique sessions. We're interested in results and say count. This will scan the trace and show us information about, and this will just take about another 15 seconds or so. This will show us information about how many different results types did we see in a trace. And this is something also worth getting familiar with, is on a running system that's looking okay, what does this typically look like? Well, one of the things you typically don't see is a lot of access denieds like you see in this one. So you can see bad network path, buffer overflows. Those are kind of standard events, cannot break op lock. But access denied, if we double click, we've just set a filter just for that. Now we're seeing Explorer access procmon because he ran procmon, so we're going to get rid of that. I'm going to say exclude that. And now we see a bunch of create files from a service host. And service host is what WebDAV operates under. You can see the accesses to temp, TFS, or TFS WebDAV, and we're getting access denieds on those. So what he did was take a look at the trace from the other system and set a filter for path, and then you can say contains, and he said TFS underscore web underscore DAV, DAV, and say, all right, now we have our two traces side by side. You can see that this one, there's a success operation on the same thing. So the first thing he did was go and set permissions on that dav directory to allow everybody full access to it. But the problem didn't go away. So now he needed to dig a little bit deeper. What is the difference between the right side and the left side when it comes to that particular operation? For that, he opened the properties dialog box that we looked at earlier. And he compared the event side by side. And if you take a look at it, really there's one key difference, and that is that this, or besides the access denied, and that is if you look at this, it's impersonating, like we talked about before. Whereas this one is not impersonating. But that was like, okay, so one's impersonating. I wonder which user account this launched under. So he went to the process tab, and he saw that they're both running as local service. So that wasn't a clue. So he kept looking. Anybody spot a difference between these two? Yeah, besides the language. Okay, that's obvious. The command line, right. The command line. One is launched, the process launched as -k local service, the other one -k web client group. So he said, wait a minute, that's interesting. I wonder if that might be the root cause of the problem. So what he did was go into the registry to where this thing is configured and set it to launch as local service and rebooted, and the problem was solved. So that's pretty kind of amazing, isn't it? Process monitor, web dav is sluggish. Compare side-by-side traces, get all the way down to, you know what the problem is? The process launched in with a different service host context on one system. Fix that, and the problem's fixed. And this took him under an hour, is what he told me. You can see it took him longer to probably get the video set up to share with me than it did for him to actually solve the problem. So process monitor to the rescue. All right, let's take a look at error dialog boxes. This one is one of my favorite cases. Why is it one of my favorite cases? Because it's my own. So I solved this case, and I thought it was so cool that I sent it to myself, and I said, hey, Mark, you should include this in one of your talks. And I said, yeah, that is pretty cool. So I'll include that in one of my talks. Thank you for the submission. This one, my laptop would go to sleep after 10 minutes when I would already peed into it. And so the way that I use my laptop is I take it home, and I have my game non-domain joined, non-anything joined system there, and I RDP into my laptop to do work on it. So I started taking my laptop home after some release of Windows 10 came out, and it would go to sleep after 10 minutes. The mouse would freeze, so the RDP window would just freeze, and the display on the laptop would blank at the same time. So I'm like, okay, there's something interesting here. So I would see that it was set in low power mode, and I'd go and I'd set it to high power mode. And then it would go back to the same setting. By the way, I told the RDP guys about this, and they said, oh, yeah, that's probably a problem with the firmware on the GPU that is triggering the power management service to say that even though the system's in use, it really should go into low power mode. In other words, we have no idea what's going on. So you're on your own. So MSIT corporate policy was like being helpful in saying you need to save energy on your laptop. So we're going to set this policy for you. So my goal was to figure out how to get group policy out of my way. All right, do not do this at home. This is to demonstrate highlighting troubleshooting techniques, not how to circumvent your company's corporate group policy settings. Right? So man, there's flies up here. They're annoyed with me. They're MSIT flies. So let me show you what I did. I said, you know what? There's got to be okay, Cortana, I don't need you right now. flies dive bombing me up here. All right, so I said there's got to be some setting here that sets the power plan in the registry, in the power options. So here's what I did. I set, let me clear this, and let me set a filter for path contains power, and added that. And then I went back to this thing and I said, oh, if I go into power saver, what happens? Ooh, a lot of activity. Oh, but there's a ton of activity. You know what I want to see? Just changes to that. So what I did was set category is right. Now, what is category is right? This category is right. What it does is only shows us the modifications. And there it is right there. That control panel applet is setting this registry key right here. So I wanted to see how group, and you can see that when I take a look at who's doing this, it is the service host, and it's executing as the system in the system account right there. So question was, that's the key that gets modified that sets the power settings. How is MSIT, how's group policy setting that key? So what I did was set a filter for this, and I did this. I said, because I knew that I was going to probably run this for a day because I couldn't predict when group policy would come and slap that back to what it was before, I went to filter options and I said, drop filtered events, which has process monitor, drop any events that aren't part of the filter. And then I just let it sit there. I set the power setting, and then I came back a little bit later, and lo and behold, I saw a modification to that by that same service host. So group policy was just calling some API to go set the power setting, which is executing this. So my next thing was, how do I stop this from working? So I did this, jump 2. And here I am in the registry underneath the power pro schemes key. And what I did was I said, Abby's the local user. And then I said, disable inheritance and convert and then remove. And so what effect does that have? Let's go back to this. So another, I just stumbled upon another classic dialog box. Windows can't make the power plan that you selected active. Choose a different one. No more data is available. Obviously, changing it to a different one results in the same dialog box. So I used process monitor to figure out what was, no, I'm just kidding. So again, that's the way that I fixed this problem. Do not, actually I'm like in Inception right here. All right, there I go. All right, so do not use process monitor for that purpose. I just wanted to illustrate it. This next case is one that a lot of you kind of probably can empathize with. How many of you are tech support for your families and friends? So how many of you gotten a call from your mother or father saying, there's a problem with Windows, can you fix it for me? So quite a few of you. I get these periodically. And this one, my mom upgraded to Windows 10 because I told her, you got to upgrade to Windows 10 because we're going for 1 billion and every one counts. So she updated to Windows 10 and she wasn't pleased with me because this is what happened. And I've reproduced this problem inside that same VM here. And that is that when she would go to Outlook, she'd get a dialog box like this. General failure. Well, actually, this is in the reproduce system. She got a slightly different one. She got, this operation has been canceled due to restrictions in effect on this computer. Please contact the system administrator. So that's why she contacted me. And then so what I did was, okay, I got to fix this. This is like Saturday morning, emergency, ticket here, troubleshooting ticket, mother, can't access links from Outlook. Put that at the top of the queue. And then I went on this web to search. Maybe other people have run into this problem. I found this knowledge base article, which was Outlook can't open hyperlinks, was the title of it. And it had in here this fix it, said, oh, you can fix this problem. Just download and run this fix it. So I ran the fix it, and it ran for a few minutes, and then it said, fixed. So I tried it, and it wasn't fixed, so I rebooted, and it wasn't fixed. So the fix it was broken. So I followed the manual steps, and then tried it. It was not fixed, so rebooted, still not fixed. When it comes to family members and friends asking you to fix their system, especially my family, where my mother brags to her friends about how good I am at troubleshooting her Windows problems, and it's a source of pride for her, the last thing I could do is go, I don't know what's wrong, Mom. So I'm in this. So let's go take a look at what I did. I ran Process Monitor. So let me clear this and capture a trace of this. And I've got filters here. So I've got a whole bunch of stuff going on. And what I did is I figured this has to do something with HTML. So I did searches for HTML. And I'm going to quickly take you to the source of this problem, which is, if I set a filter for Outlook here towards the end of it, and I came across this last thing, which is, oh, there's a HTML shell open new, command, default, and I look over at the value that it's trying to read right before the problem, and what did I see? I saw, if I can get my mouse back, where's my mouse? I've lost my mouse. I saw this, and I said, 8-2, Mom. I told you Edge. Well, so what I did was I said, okay, so there must be some problem with that key. So I jumped into the registry, and I went to open HTML file, open new command here. And I've lost my mouse. So I've right-clicked and went to rename, because golden rule, the number 2 of troubleshooting is never do something you can't undo if at all possible. You never know if you're down the wrong path, and what you're doing to fix the problem actually makes the whole situation worse. And then you're like, oh, I wish I could go back and try something different. What's the number 1 rule of troubleshooting? Oh, very good. Well, anybody figured out? Keep calm and run procmon. You're not convinced yet? That's the number 1 rule. Number 2 is don't do anything you can't undo. So I changed that, and I came back and tried this again. And I got this fixed, and so if I say Internet Explorer or whatever, I fixed it back to Edge like it should be, and now she was back in business, and her links were working. So a few minutes with Process Monitor, and I was able to fix something that even the fix-it wasn't able to fix. Now, this next case is that a customer reported to the Office team that every time they ran Office 2016, the Office 2016 installer ran. And it would eventually launch, but of course, having the launcher fire up every time you launch the tool is really annoying. And I've reproduced this problem, maybe. Well, there we go, right here. And I'm going to run Process Monitor here, have it collect a trace of what we're watching, because this problem shows up immediately. You can see that, bam, the installer just fires right up, and here in a second, Visio is going to launch. But if I repeat this operation, I get the exact same thing. This launcher starts up. Please wait. And then here a second later, Visio, it's like, OK, I finished, and Visio fires up. So what is the problem here? I captured this with the troubleshooting, the administrator, the support person for Microsoft, captured a trace of this, and they went into process tree, and they saw they're familiar enough to know that MSI exec has something to do with the problem, so they set a filter, or they said go to event for that launch of that MSI exec. And then you can see that here's MSI exec. They scrolled up to Visio. There's a lot of crap going on here besides Visio. Where's Visio? There's Visio. And set a filter for Visio. And then they did a search up to Visio, up in Visio. If you take a look at the call stack towards the end where that event is, scroll down here. They went to stack because they figured the way that MSI exec is getting launched, it's from Visio itself. And so that's why they found where the MSI exec process is started, and they looked at the process stack. Now, the way that you read this is that something in visio.exe called something in vslib.exe, a function there, which called another function, which called another function, which called another function, which called another function, which then called something in msi.dll, which is the MS installer DLL, which you can see MSI reinstall product was called. Those are symbols directly from the function names, and so what's happening here is Visio thinks something screwed up, and it's saying, time to reinstall to fix this problem, and it ends up calling this. And so what he wanted to find out is, what is screwed up that Visio has Visio concerned? And he went scanning up until he could find a call stack that didn't have msi.dll in it. And here's one. Here's like the first one. I'd save the trouble of scrolling through this, but there's no msi.dll. So he figured something around here is the problem. And what's it doing around here? It's referencing this registry key. So he jumped into the registry here and renamed this. And then came back to Visio, launched it again. Voila, problem solved. So just a few minutes with Process Monitor, having this installer dialog box, go figure out the root cause by losing a tool that I told you would be indispensable to narrow down on the root cause, and that is the call stack. Call stack led him right to the problem in that trace that it allowed him to fix the issue. So people think that's kind of cool? Okay. How many people have had to clean malware off a system? Off your own system? In the last 2 months? In the last month? Today? Anybody have malware on their system right now? Because my deal is, I'd be glad to clean it for you if we can show everybody your browser history. No. Have not had anybody take me up on that yet. I don't know why. All right, this case is a relatively simple one, but I'm going to use this case as the framework for showing you how you can use the Sysinternals tools to hunt down malware. This one is an internal Microsoft DL. It says, last week, my 9-year-old son installed a freeware video editing program, yeah, right, which I believe had some adware embedded in it. Unfortunately, blame it on your son, okay. Ever since, when we're browsing in IE, we regularly get a pane showing up on the left, see screenshot below, with related searches in something called middle rush. This seems to be hijacking clicks and then navigating to various random ad, betting, crapware sites. Needless to say, it's driving us crazy. And then goes on to say that there's an extensions folder, but deletes that and it comes back, so he can't figure out how to get rid of this thing. And then if you take a look at the screenshot, here's the related searches. It's related searches by middle rush. And then you can see there's nothing from middle rush here. And here's the directory that it tried to delete, kept coming back. All right, so already I see that this guy, it's like, what are you doing at Microsoft? Asking this kind of question. Because what's wrong with what we're seeing here? He should be using what tool? No, snipping tool. Look, he's taking pictures of his screen. right, so let's talk about some tools that you can use to troubleshoot malware with Sysinternals. One is called Process Explorer. And the way that you can use Process Explorer to troubleshoot and find malware is to leverage a giant web database of malware. Is anybody familiar with the site called VirusTotal? So this is a site that is it's got a whole bunch of anti-malware engines. It's actually hosted by Google. They bought the company VirusTotal, and which I had a relationship with already, and Google, you know, in the better interest of everybody, Microsoft partners with Google on security, things like this. And so they allowed me to continue with the integration of Sysinternals tools into VirusTotal. But what VirusTotal is a site where you can upload a binary or a file and have it scan it using roughly 50 antivirus engines and report back to you what those antivirus engines say about this thing. This is useful because some engines have updated signatures that other ones don't. So it's not always the case that if lots of anti-malware engines say it's fine, that it's not really malicious. It's just that some of the vendors haven't figured it out yet. There also could be false positives where one vendor thinks it's bad, but it's really not. And so this integration with VirusTotal is as simple as going to options, saying virustotal.com, check virustotal.com. You say, agree to the VirusTotal terms of service. What this does is launches the VirusTotal website, and you read that and you say, okay, fine, and that's what I did. And now you can see that Process Explorer has added a VirusTotal column. Let me drag this over here. And with the results, and you can see that there's a bunch of unknowns. We'll take a look at this in a second. Let's do this, where we can do submit unknown executables. So what this does is submit unknown executables. I can also have right-clicked and said submit this particular one. Caution on submitting these. If you've got a real targeted attack on your network and you submit one of these, the attackers are monitoring what's going up into VirusTotal, and they'll see that you know something's amiss if they see their file up there. So that's something to be aware of in this. Now, if you're cleaning home home and common malware type, that is a train going by, isn't it? That is, so we'll just wait. It's probably one of those half-an-hour-long trains, right? Where was I? So if you're cleaning a common infestation, then there's no harm to do this. I almost always find when I do one of these talks and I do another fresh scan of a latest release of Windows that there's a false positive type of malware update. In fact, I happened to catch one here. So this will show you, actually, let me show you how you get to this. If you click on this will take you to the report in VirusTotal, which will show you a whole bunch of information about this, including who scanned it last. And if it's been a while, you might want to rescan it because signatures have been updated, and so you might have a new signature that identifies this thing as malicious. But if it's recent, you can see this was last scanned there on July 28th. It's been a while, so I might want to scan it again if it's suspicious. But for the ones that are positive, they would show up in red in Process Explorer and with a non-zero count, and you can sort, and I don't have any of those in this list because I've got a clean system running here. But for one like this, you can see that one engine out of 57 reported this as malicious. That engine is called the Hacker, which, I don't know, doesn't sound too reputable to me. Maybe VirusTotal.com has a piece of malware on it called the Hacker that has identified this thing. So this thing has identified this as some Trojan or not. It's certainly a positive. So that gives you an idea of that. The other tool that integrates with VirusTotal and is one that you would use to clean malware off your system once you've identified it with a tool like Process Explorer or other means is autoruns. How many people have used autoruns? So quite a few of you. Autoruns, it's like msconfig, only it actually works. And it will show you information about hundreds and hundreds of the place where third parties and even Microsoft itself can extend Windows to launch things at various automatic points in time, like when you boot the system, the drivers and services all get launched. When you launch Explorer, a bunch of things get launched. When you launch IE, a bunch of plugins, browser helper objects, and other ActiveX controls and things get launched. When Explorer itself is going to launch its own file extensions, print monitors, local security authority, add-ins, boot execute systems, codecs. So this has grown over time, and also Office extensions. The Office team asked me to add this to it, so you can see Office extensions loaded at a particular point, and malware often loads here, but this is also good just for general troubleshooting your Office extensions. And for these, you can see that I've already configured it to do a scan with VirusTotal. You can go to Options, Filter, say Scan with VirusTotal, and it will automatically scan. And I don't think I've got any positives in the Everything tab for VirusTotal. But let me just set a filter here. So Options, Hide VirusTotal Clean Entries. Oh, and I do. I've got LastPass, and LastPass is identified as malicious. You can see several have these obviously false positives, including some MSIT VBS scripts are identified as false positives. Slack updaters identified. Probably from the hacker again. We click on that, let's see who's, oh, no, Rising detects this thing. So that gives you an idea of what you'd see if you've got potential malware. For each one of these entries, this shows you information about it, including the place in the system where it's configured. So here's startup, in my startup folder. And you can see that information when I select something, the version, the timestamp, the size, and the link to where this is configured if it's not in the place that it actually happens to be. If it's a configuration through registry, for example, you'll see that here. And then you can do jump to. You can do jump to entry or jump to image. Jump to entry will take us to the startup folder in this case. Just like you saw, jump to entry in process monitor took us to the registry where something was configured. And then if you've identified a piece of malware in auto runs here, then again, what I recommend you do is instead of deleting it, you disable it here by unchecking like you do in msconfig. That way you can come back if you've broken something, recheck it. There's one other tool related to malware that I want to show you before I move on here, and that is called Cig Check. Has anybody run Cig Check? Now this one I expect to see far fewer hands. Cig Check. So this tool is a file verification utility, file version utility. And for example, let's go take a look at that LastPass here in program data. Program and start up. Oh, start menu, programs, startup. And if I do Cig Check -E -U -VRS star, what this does, whoops. Oh. Actually, this is going to be looking at the links, not the actual files. So that's actually not going to work. Those are links, not files. So we'd have to go to this directory right here. So let me double click. Jump to image. And we're going to take a look at that Apollo client. And that is called apollo.client.exe. And this will do the same thing. The way that you run this is you run it against your entire system. And with those switches there, which are on a slide I'll show you in a second, this will automatically, for any images or files, if you want to look at anything, that are non-zero detected on VirusTotal, it'll take you right to the page and open it up automatically, which I just did. So this takes the same page similar to what we saw before. And that, where's my slideshow here? That entry is right here. So that's the magic sauce, and I've used this to go and find the executables that maybe even aren't configured in auto runs across the system to go find these malicious files that are laying around, because every piece of malicious file, every malicious registry key you need to go eradicate, because in some cases the malware is complicated and it might stay somewhat active even if you disable part of it. So be thorough when you go do your cleaning. So in this case, they got pointed at auto runs, and here in auto runs, this is what they saw. Right inside of auto runs under services, this thing had services configured that were watching those directories and then recreating them whenever the user went and deleted them. So by going and finding these malicious registry keys, you can see that the non-zero virus total scans over here, they were able to disable those and get the problem fixed. And you can see, haven't had a problem since while browsing. So problem solved with auto runs and virus total. All right, our final section here, blue screens. How many people have ever seen a blue screen of a Windows system? All right. It's late in the day, so I wanted everybody to get a good stretch. How many, so this is a problem, though, we've got under control in Microsoft. We've been working on this for a very long time. We've got Cortana intelligence assigned to this problem, bots working on it, and this thing is basically like we've machine learning the crap out of it, and now it's gone. So how many people have ever seen a Windows 10 crash? See, nobody raised their hand. That's just amazing. All right, how many people have seen a blue screen in public, by the way? Yep, so that's, those of you that have been to this talk before know that I like collecting these things. So let's go take a look at my latest batch, because this is always a lot of fun. Delta Airlines. So everybody's seen one at an airport, right? I'm not going to ask you to raise your hand. Airports they're blue screen magnets, airports, huh? This one is not a blue screen, but it's worth including in this. Because whenever you have an ATM that is saying it's found new hardware, you probably want to go find another ATM. All right, this is Cafe Express. Here's a billboard. Zara store. This is interesting because it's NT4. This is the NT4 Service Control Manager, and this is the Metro Authority in New York City, still running NT4. So if you need free subway tickets, let me know. This is our latest project, which is really to let you into a VR experience with the blue screen. This is at the, Aaron sent me this one. This is, I think, where is this, Aaron? Some federal agency sitting right there in like the visitor's entrance. So everybody gets to see the blue screen. This one's funny because somebody sent me this. And if you read the text, he's like, yeah, I was in the train station here. I think it's in Zurich. And he's like, I saw this blue screen. I'm like, oh, I'm going to take a picture and send it to Mark. So he goes and he's like taking a picture of it. And one of the staff comes up and says, hey, yeah, we've got another one over there if you want to take a look at it. They thought he was from IT. And so here's the auto bar. That's never a good sign. Sam's Furniture courtesy phone. This is here, you can see this right there. So kind of snippets of blue screens here. Hertz, blue screen, so can't get your rental car, sorry. This one is one of the coolest ones. It's like artwork. I don't think that they intended it to be artwork, but it could be artwork. It's like modern, cool artwork here. This is a big, long, stretchy one at a mall. You can see Fossil behind there. So multi-screen blue screens. This one's at a movie theater. It's Nike. There's another movie, IMAX movie theater. Hard Rock Cafe. This one is not one, but it is somebody running PS Kill at the Hard Rock Hotel and Casino. Iris scanner, Old Porter. This is not fake. Has anybody played this game? It's Call of Duty. So, what is it? What? Tell it. The Vision? Oh, it's The Vision. All right, so it's the wrong game. I don't play this game. But this is The Vision. This is an actual screenshot from in-game. They put a blue screen on the terminal inside the game. So it's made it into popular culture. This one I got to show you. So this is Armin van Buren playing here in Atlanta about 6 months ago, blue screen, during his performance. I don't think he did that on purpose as part of his presentation. So that's this one. So this is kind of like the latest thing that was happening lately. I'm sure you've probably seen stories of this one showing up. Not really blue screens, but you know, hey, it's time for you to upgrade. We need 1 billion, so here you go. And so that's my latest batch. All right, so when you have a blue screen, it actually just takes a few minutes to get a potential lock on exactly what's causing it. It's really straightforward, and a built-in support that's in the debugging tool makes it possible. You need a few things. You need the debugging tools for Windows. You need where the blue screen dump is. So when Windows crashes, it saves a dump file that contains the contents of memory, partial or full, of the system at the time of the crash. And you need symbols for Windows. And once you have those 3 things, the rest is pretty much automatic, maybe a little bit of manual looking to find a hint, but it's pretty straightforward. So where do you get the symbols? You can see that Windows debug with you configure the symbol server to point at the Microsoft public symbol server. There's an internal one if you happen to be on Microsoft CorpNet for the private symbols. Then the dump file is as simple as going into memory Windows and seeing if there's a memory.dump. If there's not, go into minidump and you'll find a dump file there. That's the rule of thumb. Never have to memorize when you're going to see one or the other. Just follow the steps. And then load the dump. All right, let's talk about a case that we've got to look at here and how somebody sent this to me. They ran into it. When they were upgrading their Windows 10 machine, the machine immediately went into a blue screen cycle. Boot the machine, blue screen. After the dump, the system reboots, blue screen. So they booted, successfully managed to get the system to boot into safe mode, and they started enabling services one by one. And when they enabled the firewall service, bam, blue screen. So they contacted me asking for Windows, for support from the Windows team, even though I'm not in the Windows team anymore. Actually, this was a friend of mine, and I said, you know what, I'll handle this. And so what I did was load the dump into WinDebug. And so I'm going to go load the dump. It's right here. And what this is going to do is load the symbols for the images that it sees in the dump. And then it's going to suggest that it's going to have a pointer to what it thinks might be the root cause. But I recommend that you ignore what that is and always execute bang analyze -v. And sometimes this shows up as a hyperlink you can just click on. And I don't know why it's taking so long to load the symbols. This should only take a few seconds. Let's give this another few seconds. If this doesn't work, I'm going to go ahead and show you the screenshot of what I did. Run procmon. Yep, there we go. That's good. All right, I don't know what's going on here. So let's switch over to our CAN view. And this, when I loaded the dump and I did a bang analyze -v, you see a call stack. And the last items on the call stack are the call to crash the machine here. So you can see right here, K bug check. That is the call that says blue screen the machine. And the way you read it is the same way that we talked about before. Well, these are garbage up here at the top because Windows can't parse the call stacks, but this called this, which called that, which called blah, 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 blah. In this case, there's a number of images in the list. We see the firewall client, which explains why, up here, which explains why when he turned on the firewall, the crash happened. We see some NDU thing, firewall client, TCP/IP stack, NetIO, NDIS, which is part of the networking stack, and then we saw this DNELWF64. And so this basic rule of thumb is if there's a third-party driver on the stack, it's almost always the cause of the third-party driver because Microsoft never makes mistakes with its code, so it's never a Microsoft component. And actually, that's not quite true, but it's almost always true. if there's a third-party driver, it's almost always the cause of the third-party driver. And this is one of those examples of a third-party driver. So what he did was what I did, sorry, it's my case. I did lmkvm to look at the version information on this thing. Remember, this dump is from earlier this year, and when I looked at the timestamp, inside the debugger, this information is often captured as part of the dump, so I didn't have to ask him what the version was. You can see that it's from 2011. And when I did a lookup on the web, I found that this thing is a Citrix VPN client driver. So I told him, hey, you've got an old Citrix VPN client, and your IT department hasn't updated your laptop for whatever reason, or you're on your own on this one, so go upgrade that. He upgraded that, problem solved. Windows upgrade proceeded as he expected. So a few minutes in WinDBG, steps that anybody can follow, I figured out it's a Citrix VPN client that's ancient, causing his blue screen, and got him going again. So this one, by the way, one last thing before I wrap it up here. This blue screen right here, I posted on Twitter. This is Windows 7. This is back when we were doing the free Windows 10 upgrade. And I posted this saying, here's what the latest blue screen in Windows 7 looks like. You can see this text at the bottom. It says, experience fewer crashes by upgrading free to Windows 10 now, with a hyperlink to windows.com. So I thought it was fairly obvious that this thing was a hoax. So I posted it on Twitter. I'm like, haha, this is kind of humorous. And then I started to get this. So that person was suspicious. And this person got it. And then I got a PR notice internally at the company. Reporter saw the tweet. I assume it's a joke, but given the source, it's a little confusing. I checked Windows 7 and I don't see this behavior, but just wondering if this is in the works or just a joke. So I got in trouble with PR for the tweet. But that was, I thought, pretty funny. All right, so we're here at the end of the session. I think, what I showed you is use of the tools looking beneath the surface of these error messages was my goal at the beginning. When you get one of these funny error messages or sluggish behavior, a hang, use the tools to go figure out the root cause. And that root cause might be something where you need somebody else to fix the problem, where you can work around it, like you saw me work around some problems, or you can actually go fix the problem. And pointing you at some other references, like I said, I'll be handing out those 25% discount coupons. If you have a case, please record screenshots, save the log file, send them to me so I can put them into future Case of the Unexplained. And before you leave, I hope that I've convinced you the power of Procmon, and we can all say it together one last time before we wrap it up. All right, that was pretty good. So have a great rest of Ignite. Thank you very much.